All right, so let's talk about psychology as a science and correlation and causation. This is my definition of psychology here. Um, I won't spend too much time on it because y'all are psych students. I'm sure you've heard at least part of this a million times. Um, okay, this is 275. Okay, maybe not a million times, but you've heard it a lot. One thing I would like to mention here is that you'll notice the bottom part of this definition, spirit and soul. That's something that probably isn't included in many definitions of psychology out there. Something I've recently started incorporating more in how I define psychology in my courses because, for a variety of reasons, the definition focused on the study of the mind and behavior is very much a Western psychology perspective. And spirit and soul, to me, including this in the definition, includes a um, more multicultural perspective on psychology, going sort of beyond that Western tradition and approach. And even if we look back in history to the origins of Western psychology, early psychology was often considered and defined as the science of the soul. So, in some ways, by incorporating this, I think we're going full circle back to where psychology originated within the Western scientific tradition. So something I wanted to mention there. And there are lots of things we can do with psychology, lots of ways we can describe how it's used, lots of fields within psychology, or sort of like focus areas like clinical, forensic, social, developmental, cognitive, so on and so forth. But broadly speaking, we think about psych and what you can do with this degree. There are kind of two broad ways we can categorize it. Might not necessarily be all inclusive, but we can say that psychology is a science and psychology is a practice. And so that science piece is generating and sharing knowledge, such as through research methods, the whole point of this class. And psychology is a practice, which is applying that knowledge to address real problems. So it could be in organizations, if we're having, I don't know, problems with lots of turnover, problems with teamwork, whatever it may be. Um, or it could be, for example, with individuals, such as in therapy, right? The whole field of clinical and counseling psychology. And for our lecture here, let's go into science a bit more deeply. Before I move further, I would like to mention these two kinds of reasoning. When we think about the scientific method or research methods, I think most people often think of deductive reasoning. But I would like to note that that's not the only way we can generate knowledge. So starting with inductive reasoning. In inductive reasoning, this all begins with observations, right? So um, science today, right? It all started somewhere, and I'd say any science, if we go back far enough, we're going to find that it started with people just observing the natural world around them or the universe around them. Whether it was looking at the stars, looking at human behavior, common themes, and what people are doing, we develop generalizations from those observations. So, in other words, if we see something happen enough times, or we see a common pattern or theme behind our observations, we might generalize that to say, okay, there seems to be something going on here. Then we can develop some sort of paradigm or theory. Some paradigm or theory, in other words, something that basically states, constitutes, summarizes um, those themes and generalizations in a concrete way that then can be tested further to see if our theory is right, holds water, or if it's something that needs to be modified. And then deductive reasoning is kind of the opposite, in that we take this theory, this broad um, statement of sorts or summarization of these patterns that we see. And then from there, we can develop predictions and then develop experiments to test those predictions, right? And so, again, this is the piece I think people often think about, but that's certainly not the only way of knowing or way of um, doing research, right? Testing the world around us. But nonetheless, psychology being a science is rooted in the scientific method. This is one way of visualizing this. There's lots of different graphics out there. I'm sure y'all have been exposed to this before. Like, I think I first got exposed to the scientific method in like fourth or fifth grade. Um, so, and this is something we'll come back to throughout the course. Um, but I wanted to mention that this is one way of knowing, one way of generating knowledge. But again, there are certainly other sorts of perspectives and ways of knowing out there. But something I did want to reiterate early in this course is correlation and causation. Um, y'all have probably heard this come up in other psych classes at this point. Um, and so this might be just refreshing some memory of what you've already learned, but nonetheless, I think it's an important thing to hit on because it's something that's often confused in both doing science, doing research, and just in how we consume research, such as through the news. There's all sorts of news articles out there about some study proves X, Y, and Z thing, but sometimes people are actually misinterpreting things. Um, so to dive into this a bit further, this is a perfect example right here of correlation not equaling causation. So this is a comic from the Family Circus, if you've heard of that. And so they're on an airplane here, and the kid's saying, I wish they didn't turn on that seatbelt sign so much. Every time they do, it gets bumpy, right? Okay, he's assuming, given his, I don't know how old he is, I don't know, 6-year-old brain or whatever, that the seatbelt sign leads to it being bumpy, right? That the seatbelt sign causes this bumpiness, when really, if you fly on an airplane, you know that's not true. And so to define this in more explicit terms, causation refers to causal relationships. So in other words, A causes B, B causes C, whatever it may be. So for example, if I eat, I was blanking on examples, so this is what I got. Eating potato chips for 7 hours, it's probably going to lead you feeling like you're dying, right? If you just ate potato chips for 7 hours straight. In fact, I don't even know if you could. I'm not encouraging you to test this, but that's a perfect example of one thing causing another. Correlations then are different. And so to just reiterate what correlations are, these numbers, correlations are statistical relationships looking at the strength and direction of two or more variables in the relationship between them. So people depict this in different ways. Graphs might land more easily for some students, Venn diagrams for others. But basically, we're saying we have these two things here, for this example, X and Y. We're trying to understand the extent to which those relate or influence one another. And the numbers themselves, if we look at a correlation coefficient, for starters, they indicate the strength of a relationship, so how closely things vary together. So we could have R, lowercase italicized r is usually the label we use for correlations. So we could have an R that's between -1 and +1, so it could be minus 0.96, could be plus 0.38, right? Whatever it may be. And that's indicating the strength. Oh, pardon me. Um, and the direction's indicated by the sign, so it could be positive or negative. A positive correlation means that things increase or decrease together. So if we're looking at A and B, X and Y, a positive relationship means that as one goes up, the other tends to go up too. Negative means the opposite, right? And so one way I describe this in my intro courses is you can kind of think of it like friendships or interactions. Like if you have a positive interaction with someone, you'll probably want to keep hanging out with them. So that will mean that you're going places together. Whereas if it's a negative relationship, um, or you have a negative interaction, you probably don't want to continue hanging out with that person, or you might need to take a break, right? Take a breather. Um, and so in that case, you're going opposite ways, right? This isn't a perfect analogy, but I think it can help if you need some kind of just mental trick to keep these things straight. Um, yeah, for what it's worth. And so, like to test this quickly and give you some brain teasers, let's think here: positive or negative? Hours spent studying and Sci 250 or Sci 275 test scores. Do you think that would be a positive or a negative relationship? Or in other words, the more hours you spend studying, do you think you'll do better or worse on your test? Probably better, assuming you're studying and not just like sleeping in your textbook, which I've done before. Don't recommend because it doesn't work. So that'd be an example of a positive relationship, all right, or positive correlation. Another example, miles ran per week and weight. Or in other words, if you run 100 miles per week, do you think you would weigh more or less than if you ran 50 miles per week? Well, you probably weigh less, so that means that this is a negative relationship, right? The more we're running, the more calories we're burning, the less we're going to weigh, holding other things constant. So it'd be negative. Oh, sorry. Then the strength of a correlation is indicated by the absolute value of R. So in other words, if we ignore the plus or minus sign, basically the closer the number itself is to 1, the stronger that relationship is. So to visually depict that, if we have A and B using a Venn diagram and a graph as an example. A correlation of 0 means that there's no overlap. If we look at this on graph, like these data points, each data point represents some participant or some specific measure of the relationship between X and Y, A and B. We can see that there's really no correlation. They're all over the place. Whereas as this number increases, we see more and more overlap. And on a graph, we see basically a tighter line, right? As our correlation increases or gets closer to 1, we're seeing more and more of a direct linear relationship, which will reach at a correlation of 1. And then the same is true in the opposite direction. It's just now the line is going down, right, rather than up, because as one is increasing, the other is actually decreasing now. And so this graphic, I think, might help to keep that straight. So again, a perfect linear relationship at 1 and -1. The key difference is the direction of that linear relationship. And so, yeah, generally strengths about correlations. Actually, yeah, this might be more than we need to go into right now. But a key thing to mention here is that correlation does not equal causation, right? We can look the way things fluctuate. We can basically study things we can't manipulate through experiments or through research for practical or ethical reasons or any other sort of reason. Um, we can get a sense for how things relate and vary together or not. However, we can't say that one causes the other. So my warning here is to beware of spurious correlations. Um, Basically meaning that just because two things are correlated doesn't mean that one causes the other. So if you look at this, there's a whole website about this. Um, but it includes some random correlations that clearly aren't based in real causal relationships. For example, the number of people who drowned by falling into a pool correlates with the number of films Nicolas Cage appeared in these years. Um, so if one is assuming that there is a causal relationship here, we could say that, okay, Nicolas Cage needs to stop doing movies because he's killing all these poor people who are drowning, right? Which obviously isn't true. These things aren't practically really causing one another, but there's still this spurious relationship that we can see. Because if we collect enough data on anything or on everything, we can see these random relationships appear by chance. Another example, divorce rate in Maine correlates with per capita consumption of margarine. Um, yeah, I'll let you unpack that one. Probably not. Well, I suppose one could make an argument. Maybe it's because people are consuming so much margarine that they're getting divorced. I don't know. I don't know. I'll let you decide. Point is, correlation is not equal causation. I'll stop there. See you next time.